how to use the gradient and y-intercept tool. I'm going to push mode, and then you'll see there is the option for number 3, stat. Now, because it's a linear graph, we can see looking at the sort of information here that it's going to be a linear graph. We're going to press 2. So A is basically C, and B is M from y equals mx plus c. So press number 2. Then you'll see it's got y and x values. So we're going to now enter the force as our x values. So that's going to be 25. We'll press equals 80 equals 135 equals 190 equals 245 equals and 300 equals. So once you've put those in, we're then going to go up to the top again and enter all the y values. So z and 7 plus 31 plus 50, 66, 93, and 106. Right, once you've entered all the values, then comes a bit of a weird step. You press AC. When you press AC here, it takes you back to this. Now it looks like you've deleted everything, but if you go Shift 1, it takes you to the options for all the data. So from here, it's 5 because we want a linear regression. So we press 5. A represented our y-intercept. So if we press 1, it'll give us a y-intercept, which is close enough to 0, as you can see over there. And then if we press AC again, Shift, Stat, back to regression, and press 2, that's now going to be our gradient. And you can see that I did plot this whole graph, and even reading from the graph, we get that same gradient there of 0.62. So the nice thing is the boys can at least see if their gradient's correct. They can also work this backwards, put the data in that they get, find out what the gradient should be, and then draw the line. Instead of taking the y and x values from here, they can just go backwards and get it for themselves. Or get the gradient and then figure out what that and that and that and that should be. Pass through those lines and you get a perfectly drawn gradient. Okay. Then the next one, this can also do a whole lot of other things. So if we go back here again, you can go Shift 1, get the sum of all the data, min, max, variation, which is standard deviation, whatever. But yeah, so 3, you can find out the sum of all the x values, for instance, if you need that. Okay, now getting to the x solve and y, using solve for x. Okay, so I'm just going to use this from the projectile motion questions. So now we need to get t. So to get t, just need to take it out of stat mode. So back to mode, press mode, take it back to comp. Right, so to use solve for x, we're now going to have basically type this in. So negative 200 alpha equals 50. Now, because we don't have time, we can just say alpha x plus half negative 9.8. And we want alpha x, and shift. We don't need shift, we just need to square it or cube it. Okay, now if we press equals, it's just a syntax error. So we can cancel that. Pop it in again, negative 200. Alpha equals 50x plus half times negative 8 times x squared. Then place shift solve. Solve for x. Let's just start it at 1. Okay, so this is not giving us a nice answer. So when you get to this, we can see that the answer can't be -3. So shift solve again, and let's solve it for 10. Okay, and that gives us 13.27. That looks like it's about the right answer. So t is equal to 13.2728 seconds. Now the other way to do this is to take our equation here and convert it to a quadratic. So we're going to make everything equal to 0, and then we just need our ax squared, bx squared, so on. So it's going to be negative 4.9 t squared plus 50t plus 200. Now to use this, we need to go get the quadratic equation. So I'm just going to cancel all of this in the calculator. And we go mode. Now it's 5 equations. We look for the equation that represents quadratic, ax squared, bx squared plus c. So that is number 3. And we just type these in. So negative 4.9 equals 50 equals and 200 equals. So equals, and we get x1 is equal to 13.28 time. Okay, so that is how to use the gradient tool, the shift solve tool, and then quadratic tool. Cool.